Welcome to the Explainer. So you've got exactly 90 minutes to secure your glory. Today we're building your ultimate game plan for Cambridge exam victory. Whether you're sitting for syllabus codes 0580, 0606, 4024, 4037, or 4040, the pressure in that room is very real. But right now we're going to hyper-focus on a specific battleground that universally trips candidates up. IGCSE Additional Mathematics 0606, specifically evaluating definite integrals. Now, most students walk into this exam treating it like a casual practice match. But listen, this isn't just about crunching numbers. It's about strategy, precision, and knowing exactly how the examiner's mind works. By the time we finish up here, you're going to have an elite game plan that completely transforms how you approach the absolute hardest questions on your paper.
So why do so many incredibly hardworking students bleed easy marks when evaluating definite integrals? You'd probably think it's because they simply don't know the math, right? Well, the painful reality uncovered right in the principal examiner reports is quite different. The vast majority of candidates lose marks because they completely lack a strategic framework for their methodology. They totally understand the calculus, but they fail at evaluating the evidence and drawing the conclusions the exact way the assessment framework demands. You see, when you're dealing with definite integrals, you aren't just finding some area under a curve. You're demonstrating your capacity for systematic analysis and evidence-based reasoning. If your approach is chaotic, your marks will reflect that chaos, regardless of whether your final numerical answer just so happens to be right.
Here's our quick roadmap for today's Explainer. We're going to hit the challenge, building core principles, the procedural framework, top examiner warnings, and we'll wrap up with mastery and evaluative thinking. Let's jump right in.
Part 1. The Definite Integral Challenge. To really get why exam strategy is a make-or-break deal, let's look at two archetypal students staring down a real Cambridge mathematics past paper question. First up, we've got Alex. Now, Alex's strategy is fundamentally flawed because he just overloads the paper with raw mathematical facts but provides absolutely zero structural analysis. He literally writes down every integration rule he can possibly remember, basically hoping the examiner will just hand over marks for effort. There is no logical flow. Then we have Sam. Sam is fighting the clock and rushes straight to the calculation, entirely ignoring the command words in the prompt. When the question clearly says evaluate, Sam just slaps down a single final number, without showing the causal relationships or clear working. Both of these students are throwing away points, but not because the math is too hard. It's because their approach lacks absolute discipline. They're completely missing the fundamental requirements of the assessment objectives.
Moving on to Part 2, building core principles.
If Alex and Sam want to actually stop hemorrhaging points, they've got to totally flip how they view the exam itself. The method mark strategy is the conceptual framework you need for evaluating definite integrals. It draws heavily on established principles of systematic analysis and evidence-based reasoning. Because here's the secret: examiners award method marks for the process. Let me say that again. Marks are awarded for the process, not just that final answer. Top-performing candidates show a conceptual understanding that transfers smoothly to unfamiliar contexts. Plus, principal examiner reports specifically highlight the candidates who reference cross-topic connections, showing exactly how this integral ties into other syllabus areas, achieve significantly higher marks. The academic benchmarks here prioritize analytical depth way over superficial breadth. You have to prove exactly how you got from point A to point B with absolute, undeniable clarity.
To achieve that kind of clarity, you need a system. Enter the Peel framework. Point, evidence, explanation, link. Before we continue, subscribe to our YouTube channel, Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, back to Peel. When breaking down the command words in your math exam, top students structure their mathematical steps just like a compelling legal argument. You make your point by stating the correct integral formula. You provide evidence by explicitly substituting the exact limits and data from the question. You give an explanation by showing your step-by-step integration process with crystal clear working. And finally, you link your result right back to the specific context, providing the final evaluated answer with the proper units.
Part 3. The Procedural Framework.
All right, so now that we've got those core principles locked in, let's look at the ultimate standardized sequence for systematic processing within definite integrals. Step 1. Extract the relevant data. You must accurately pull the correct limits and functions from whatever text or tables they give you. Your data interpretation skills here are absolutely critical. Step 2. Select the analytical framework. Identify the key elements and apply the right mathematical principles. Step 3. Execute with clear notation. This means actually showing your causal relationships and executing your analysis with working that is incredibly easy to follow. Step 4. Verify and present your results. Check your numbers and present them in the appropriate format using the correct terminology. The syllabus is unbelievably strict about this specific sequence. If you skip a step, you literally risk skipping a whole grade boundary.
Okay, it's time for a transformation. I'm throwing a mental 60-second challenge your way right now. Imagine a complex mathematics data source in front of you, and think about exactly how you would rewrite Alex and Sam's flawed answers using that 4-step procedural framework we just covered. Picture those red pen marks transforming into green check marks as you meticulously extract the data, select your framework, apply the notation, and verify your results. Stop scrolling. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Part 4. Top Examiner Warnings. So, we've built up your offensive strategy. Now we've got to look at the traps. Diving directly into the Cambridge Principal Examiner reports reveals a massive goldmine of insider knowledge. It shows exactly where thousands of students throw away their grades year after year. Listen to this quote. "The classic mistake is providing generic answers not specific to the question context. That is a massive examiner alert when evaluating definite integrals. You absolutely cannot just run the calculation in a vacuum. It is an absolute necessity to link every single mathematical point, every assumption, and every conclusion back to the specific scenario they gave you. If the integral represents a physical area, a volume of revolution, or some contextual boundary, your answer has to reflect that reality. Generic math just gets generic grades."
According to the senior examiners themselves, there are 3 massive mistakes you need to avoid. Mistake number 1, answers are too vague. Examiners are desperately looking for specific, precise details in your working. Mistake number 2, forgetting to check your format and presentation. The presentation of information in definite integrals follows incredibly strict conventions. Proper headings, correct terminology, appropriate formats, and clear annotations are not optional, they are strictly enforced. Mistake number 3, ignoring the given context, which we literally just talked about. To help you lock this in, I want you to create a memory hack acronym right now to recall these presentation factors before you even walk into that exam hall. Remember, VFC, vague, format, context. Seriously, don't let these be your downfall.
If you evaluate a flawed sample paragraph, you can spot the problem sentence almost instantly. A vague, generic answer might actually integrate correctly, but it completely leaves off the clear notation, it skips the rigorous formatting, and it fails to state any limitations or assumptions. In sharp contrast, context-specific precision uses the proper terminology, it structures the reasoning logically, and it explicitly draws evidence-based conclusions. It's essentially a perfect Peel paragraph applied directly to higher-level mathematics. The difference in marks awarded between a vague answer and a precise one? It's honestly staggering.
Part 5. Mastery and Evaluative Thinking.
Here is the final complete answering system, the 3 absolute rules that guarantee top marks. Rule 1, command word decoding. You have got to dissect exactly what evaluate means in the context of your specific question. Rule 2, Peel framework application. Structure that mathematical argument with point, evidence, explanation, and link. Rule 3, the time management matrix. You have 90 minutes. You must allocate your time based on the method marks available rather than just frantically rushing to find a final answer. This system works seamlessly because the academic benchmarks for Cambridge prioritize analytical depth over superficial breadth. When you follow these 3 rules, you are handing the examiner exactly what they are trained to look for.
Now let's see how this ties directly into evaluative thinking. The absolute top-scoring candidates, they don't just calculate, they demonstrate high-level evaluative thinking. But what does that actually mean in Additional Mathematics 0606? It means you actively question assumptions. You consider different perspectives or alternative interpretations of the data in front of you. You identify limitations in the mathematical models you're using, and you justify every single procedural decision with hard evidence. A true evaluation of evidence quality requires you to state how the assumptions you made might actually affect your final conclusions. It's this exact level of critical analysis that pushes a standard candidate right into the top percentiles.
Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Let that sink in for a second. 2 full grade boundaries just by shifting your methodology from raw calculation to systematic analysis and evaluative thinking. It completely transforms your mark potential. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at @acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @theacetheexams_IGCA and click that bell. Don't let another exam pass you by.
I want to leave you with this final provocative question. When you sit down for that exam, when the clock starts ticking on your 90 minutes, will you just solve the equation like Alex and Sam, or will you use evaluative thinking to justify every single mathematical decision? The choice is entirely yours, and it absolutely determines your final grade. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.